Hello and welcome to the Build a Development Environment with AWS and Terraform Resume Foundations project. So a Resume Foundations project is a short project that is tailored to cover the important aspects of a technology in order to help you build the foundations necessary to build your own projects and apply them to your resumes. So let's take a look at what you're going to find in the course. In this 2-hour project centered around Terraform, you're going to use VS Code and deploy an AWS EC2 instance along with the VPC, Internet Gateway, security groups, etc. that will serve as a remote development environment that you can log into directly from VS Code. We'll utilize several Terraform tools and functions such as Terraform State, Format, Replace, Console, Variables, Conditionals, File, Template File, and more. We'll also use AWS user data and a local exec provisioner to bootstrap the EC2 instance and add its connection information to your VS Code SSH configuration file, allowing you to modify it for your own projects. Since we'll make heavy use of documentation and highlight the process behind developing a brand new Terraform deployment, you'll have the skills you need to dive deeper into Terraform and add this extremely in-demand skill to your resume. So what are you waiting for? Sign up today and don't forget to Terraform apply yourself. Hello and welcome back. In this quick lesson, we're just going to take a look at what we're going to build throughout this course. Now it's a fairly straightforward build. We're going to cut it down to the bare necessities because you don't need much for your development environment. The more resources we add, the more can go wrong. So let's just make sure that we keep it as small as possible. And then of course, as you develop new requirements, you can build out your environment to meet your needs from there. So what we're going to do is we're going to use VS Code on our terminal. And then we're going to use the Terraform configuration files, providers, variables, main, terraform.tf-vars, which of course we will be explaining all of these throughout the course. And then we've got a configuration file here that's going to configure VS Code based on the IP and other information of our developer node. And we've got our user data that's going to bootstrap that node. Now in AWS, we will build out a VPC. We're going to build out an internet gateway, public route table, a security group, a public subnet, and an EC2 instance. So all of this together will form our developer environment. And once we're done, after all of these files have been processed and everything is good to go, your VS Code terminal will have access directly to this EC2 node to deploy a remote SSH session, which will allow you to have file and SSH access to your EC2 node to run whatever you need. So that's a very high-level overview. Go ahead and mark this lesson complete. Let's go ahead and get building. Hello and welcome back. In this quick lesson, we are going to set up the keys and permissions for the user we're going to use to deploy our Terraform resources. So let's start out right here in the AWS console, and let's go to IAM. Now, as you can see, I've recently visited, but just in case you haven't, you can just search right up here in the search bar. Let's click on that. And now let's click on Users. Now within Users, you may see a lot more information here. I've actually hidden most of mine. Let's go ahead and create a new user. So we'll click on Add Users. And for the username, feel free to use whatever you'd like. I'm just going to call it VS Code. And now I'm going to choose Access Key Programmatic Access. We're not bothering with a password. This is not going to be a user that logs into the console. So go ahead and click that. And next, Permissions. Now as you can see, I've got a group of admins. You can of course create a new group, or you can just attach the policies directly. And I'm going to do that. Just click on Attach Existing Policies Directly, click on Administrator Access, and then click Next Tags. Now feel free to tag it if you'd like to, I'm not going to bother. And next review, we've got right here our username, programmatic access, and administrator access. Go ahead and click on Create User. And right here, you'll see that you've got your access key ID and your secret access key. Go ahead and download that CSV. And once you've done that, go ahead and mark this lesson complete. Come on back to the next one and we'll get VS Code all set up. Hello and welcome back. In this lesson, we're going to get Visual Studio Code all set up so that we can start deploying our Terraform resources. So let's get started. As you can see, I've already installed Visual Studio Code. It was a pretty straightforward process. I am on a Windows machine, but this of course will also work on a Mac or Linux. So go ahead and first things first, let's get the AWS extension installed. So click on the extensions icon here on the left, and then search for AWS. And once you've done that, we've got this AWS toolkit here. Go ahead and click Install. Looks like everything installed fine, so I'm going to go ahead and close this pane and close this tab. And then I'm going to click on this little AWS icon. As you can see, we've got Connect to AWS right here, but before we can do that, we need to get some credentials installed. So head up to View and Command Palette. Then as you can see, I've searched for this before, but if you need to get to it, you can type AWS and then start typing Create Credentials Profile, just like so. And then open that. And as you can see here, I've got a credentials profile called VS Code. If yours looks different, make sure that you get this looking the same if you want to follow along in the course exactly. But of course, if you don't or you're comfortable making simple modifications, you can name this whatever you'd like. But what we need to do is populate this AWS access key ID and secret access key. So go ahead and open your credentials file and paste this information in, just like so. All right, and once you've done that, go ahead and Control S to save this file. You should not have this white dot that was up here before, and close this tab. And then click on Connect to AWS. And you should see your profile right here. If not, you can obviously type Profile, VS Code, if you need to, and just click on that. And default region of US East 1. I actually don't want that region. I'm going to use a different one, but whichever region you choose, you can choose that here. I'm just going to say no. And I'm going to add US West 2. That's the region I typically use in my courses because there's so much default stuff that goes on in US East 1. I just prefer to stick with US West 2, but this is totally up to you. So once you've done that, you can go ahead and minimize that. And then open the extensions panel again. Let's go ahead and add something that'll give us a little Terraform syntax highlighting. Let's go ahead and type in Terraform. And as you can see, there is an official Terraform extension here. It's rated 2.5. It is pretty buggy. It might be better now that you're watching this video. Feel free to choose this one if you'd like, but I'm actually going to use this one here. It's just got a higher rating and it's been pretty consistent for me. So I'm going to install this one, just like so. All right, and I'm going to close that tab and close my extensions. So now that we've got our extensions installed, let's go ahead and create our working directory. So I'm going to go ahead and click on Open Folder, and I'm just going to set mine up in the Documents directory. Feel free to set this up wherever you'd like, of course, just like so. And then I'm going to create a new directory. And I'm just going to call it Terraform, just like so. All right, and I'm going to open that and hit Select Folder, just like so. All right, so now we have a working directory. We've got our extensions installed. Everything is ready to start the course. So go ahead and mark this lesson complete. Come on back to the next one and let's get started. Hello and welcome back. In this lesson, we're going to configure the AWS provider and run a Terraform init to initialize Terraform and get it ready to deploy AWS resources. So let's get started. So here I am in the AWS provider documentation within Terraform. And a provider is basically used by Terraform to interface with the API of whatever infrastructure you're trying to build. So in this case, you're trying to build AWS infrastructure, so you use the AWS provider. If you're using GCP or Azure or VMware or whatever else, you will use their respective providers. So as you can see, it's pretty straightforward. Since we've already provided credentials, we don't need to provide those within the provider block here. If you scroll down, you can see there's actually lots of ways to add these credentials, but again, we already have a profile, so all we need to do is access the shared credentials file, just like this. So let's go ahead and we'll keep it fairly simple. I'm just going to copy this here. And then within our Terraform directory here, which we created earlier, going to create a new file, and let's call this providers.tf, just like so. And we'll paste that in. Now I'm actually going to remove this version block here because you may be in the distant future and not on version 3 anymore. So again, I'm going to just remove that and let you download whatever version is current. Now, after that, we need to add our provider block. That is the required providers block, and that provides configuration that Terraform needs to know about. But the provider block itself provides the information needed to access AWS specifically. So if you scroll down here, you can actually see that we have some usage examples, and we have one right here with shared credentials file already here for us. So let's go ahead and just copy this one. And I'm going to paste that right here. Now again, typically I'd type all of this out, but since this is a very quick course, I want to make sure it is as streamlined as possible for you. So here, I'm just going to remove this, and I'm just going to add that little squiggly right there to indicate the home directory, .aws/credentials, because that's where our credentials file is stored. Now, if you've moved it, of course, you'll want to change this, but this is actually the default for Windows and Mac, so you should be good to go. Now, for the profile, remember that was named VS Code, and the region is US West 2. So this is what you should have here for the provider. Again, if the documentation did not provide this exactly, of course, just copy it from here. All right, so now that that's done, let's go ahead and run a Terraform init to initialize this and connect to AWS to ensure everything works out. So I'm going to click on Terminal and New Terminal, just like so. And let's go ahead and I'm going to pull this up a little bit, clear this screen, and let's go ahead and run Terraform init. All right, Terraform has been successfully initialized. As you can see, we've got HashiCorp AWS version 3.71.0, at least that's my version. If your version is different, that is perfectly fine. Also, you can see that Terraform has created a lock file, Terraform lock.hcl, and what that's going to do is ensure that the version is frozen. Again, you can change this if you'd like, and this should be the current version you're using. But this is something you might want to keep in your GitHub or GitLab or wherever you're storing your code repository so that you can ensure that every time you run this code, it always uses the same version of the provider and you have a much lower risk of having some sort of issue with an upgrade. So it looks like everything is all nice and initialized. As you can see here, I can do this drop down and you can actually see the provider, which for Windows is an IaC. And for Linux and Mac, you'll actually see another binary there. But this is compiled and you're not going to go digging through it. So everything is ready to go now to start deploying resources. So go ahead and mark this lesson complete. Come on back to the next one and let's get deploying. Hello and welcome back. In this lesson, we're going to use Terraform to create the primary building block for most AWS deployments, the VPC. So let's get started. As you can see here, the VPC is actually pretty straightforward. You basically specify the resource, this being the actual resource, as you can see, AWS VPC. This is a static value that cannot be changed. If you change this, you're not going to deploy a VPC. Now after that, we've got the name for this VPC, which in this case is main. We can name it whatever it is we want. This is a logical name that only Terraform knows about, so this isn't going to show up in AWS anywhere. So again, make sure you understand that, but this is how we will reference this VPC in future lessons. And then we just provide a CIDR block. Now there are also lots of other options that you can specify here. As you can see, it gets pretty complicated. If you go down to the argument reference, you can see that we have a lot of stuff here we can use, such as enable DNS support, which defaults to true, and enable DNS hostnames, which defaults to false. So let's go ahead and let's utilize this to create a VPC. I'm going to bring my VS Code back over here, and I'm going to create a new file, and we're going to call that main.tf. So I'll create a new file, main.tf, just like so. Make sure that it is in the proper directory here and you didn't accidentally add it within the Terraform directory here. And we've got that up. Now, the way these TF files are processed is they're processed as if they're all the same file. So if you have 20 TF files in here, all with different resources, they're all going to be processed as if they're the same file. So keep that in mind. You can split up your code however makes sense to you. You can have a compute.tf, networking.tf, whatever you'd like. It's all processed the same as long as it's in the same directory. So let's go ahead and create this VPC resource. So I'm going to type resource AWS VPC, just like so. So this, of course, is specifying that I want a resource. Where here I wanted a provider, here I want a resource. Now, once again, let's name this VPC. I'm going to name it MTC for more than certified, VPC, just like so. And then I'm going to use some curly braces here. This will wrap our entire resource. Then I want to specify that CIDR block. And in my case, I'm going to do 10.123.0.0/16. If you've taken my other courses, you've probably seen this CIDR block before. Now under that, let's say I want to enable DNS hostnames. As you remember, DNS hostnames defaults to false. So if I want to enable this, I need to make sure that I add it. So I'll go ahead and enable DNS hostnames equals true, just like so. And if I wanted to, I can also say enable DNS support equals true. Now we don't have to because this is assumed. However, depending on your development team, you might want to ensure that this is explicitly mentioned. Your team may not understand what's default for your VPC, and it might be very helpful to be very explicit and specify some things that default as true just to ensure that one, it's easy to modify, and two, your team knows that this is enabled. Again, not required, but it's something you might want to do. Now, under that, we're going to specify some tags. And I just want a name for it, and I'm just going to name it dev. Just like so. So I know that this is my dev VPC whenever I go searching. All right, and as you can see, I've got my two curly braces here. One is to enclose these tags, and one is to enclose this resource. So that's all I need there. Let's go ahead and run a Terraform plan, just like so. And what this is going to do is let us know what we're trying to build. Just like so, as you can see, we've got all of these new pieces that are going to be created within our VPC resource. We're going to have our CIDR block, an ARN will be created, which we won't know until we actually apply it. And the same with a lot of this other information, such as the ID. We will not know until we apply it. Now, as you can see, we've got these green plus marks. That means that these are all being added. So that all looks good. We've got one actual resource, AWS VPC.mtc VPC to add. So what we want to do next is apply. We'll run a Terraform apply, just like so. And as you can see, it basically runs another plan and then asks us to confirm. And to confirm, I'm going to type yes, scroll this up a little bit, and our VPC is being created. All right, perfect. Our apply is now complete. So if we go over here to our AWS pane, I'm going to click No here. I do not need US East 1 right now because I am in US West. I'm then going to click on Resources. And as you can see, I've actually got some resources already shown here. That's from a previous installation. If you click on this little sprocket, type AWS ::EC2 ::VPC. You can also search for VPC. You can see that that's been added. Go ahead and check mark that and click OK to ensure that resource is added. Then if you click on it, you'll see our brand new VPC is here. So there's our CIDR block, our default network ACL, default security group. It looks like everything is here. Enable DNS hostnames is true. Enable DNS support is true. All right, so perfect. So that works. Go ahead and mark this lesson complete. Come on back to the next one and let's continue the course. Hello and welcome back. In this lesson, we're going to take a slight detour from building to dive into the Terraform state a bit so we better understand how information about our deployment is stored for Terraform to use. This is probably one of the most important concepts with Terraform, so make sure you read over the documentation a good bit if you really want to understand how things work. But essentially, we're just going to take a look here and see exactly what is stored in our state as we deploy resources. As you can see, there's a lot here in the docs, and we're going to explore several pieces of this as we build our infrastructure. So here we are, right here after we have now deployed our fresh new VPC. As you remember in our AWS resources pane here, you can see all of this wonderful information about our VPC. Now, another way we can see what we've deployed is to head into our Explorer and right here, our terraform.tf state file. As you can see, we have a lot of the same information: default network ACL, default route table ID, security group ID, the VPC ID there. As you can see, all of that is here. VPC ID, default network ACL, security group, etc. Now it's formatted a little bit differently, but it's, for the most part, the same information. And this was all pulled right from the AWS API. So now typically you're not going to want to traverse this TF state manually, as it will normally be stored somewhere off-site, whether it's in Terraform Cloud or in AWS or somewhere else. So we have several different tools we can use, command line tools, to access the state. So let's take a look at Terraform state list, just like so. As you can see, we only have one piece in our state, one resource, that MTC VPC that we deployed. So if I want to see that information within that VPC, I can run a Terraform state show AWS VPC.mtc VPC. As you can see, shown right here. If I hit enter on that, we have all of the same information. So we've got information here from our API. We've got information here within our state, the state file specifically. But this is all the same information. It's just formatted a little bit differently. Now you can output as JSON and really manipulate that output, but we're not going to dive into that right now. All right, and of course, if you want to see the entire state, all you have to do is just type Terraform show. So keep that in mind. Terraform state show requires you to insert a resource. Now, Terraform show is just going to show you everything that you've got, which of course can be massive if you have a very large environment. So those are the basics of our state and the information that's being stored within it. There are a lot of commands that you can use to manipulate that state, to refresh it, to migrate it. But we're not going to dive into that right now, but just know it'll be very beneficial to you if you dive into the documentation a little bit and just read all about state, as it is the most important feature within Terraform. All right, so that's all for this lesson. Go ahead and mark it complete. Come on back to the next one and let's get back to building. Hello and welcome back. In this lesson, we're going to check out a command almost as fun to use as Terraform apply, but much more fun to say. And that command is Terraform destroy. So Terraform destroy is pretty straightforward. Basically, it's going to destroy anything that we have created. And as you can see here, you can actually run a Terraform apply -destroy, but we typically just use Terraform destroy. There's not a lot else going on here that you need to really worry about. You can run a Terraform plan in destroy mode, which will tell you what happens when you destroy. So that can be fairly useful if you need to test something out. But for the most part, we're just going to run this Terraform destroy. So let's do that. Let's knock out this VPC that we created, completely delete everything we have applied. So just run Terraform destroy, and then we can just use a -auto approve if we don't want that confirmation dialog. Again, useful in automation. Probably wouldn't use this in production if you're typing it yourself though. Let's go ahead and run that. All right, the destruction is complete. Everything is gone. So that's really all you need to know there. So go ahead and reapply it, as we're going to need this VPC for pretty much the remainder of the course. So Terraform apply, auto approve, just like so. All right, all set. We're back to where we left off. You saw how easy that was. This is one of the great things about Terraform. Infrastructure just comes and goes as you need it. So go ahead and mark this lesson complete. Come on back to the next one and let's continue the course. Hello and welcome back. In this lesson, we're going to deploy a subnet to which we can deploy our future EC2 instance. So let's get started. As you can see here in the docs, it's pretty straightforward, although there are a few more options we're going to want to add. One of them, and if you scroll down here, is map public IP on launch. Default is false. We want to make sure that our instance receives a public IP address whenever we launch into the subnet. So we'll want to ensure we add that. So let's go ahead and get started. All right, so right here under my VPC, we're going to add another resource, and that resource is AWS_subnet, just like so. And then let's go ahead and name it. I'll just use MTC_public_subnet, just like so. And you don't always have to add a prefix like this. Although I've been doing it for so long, if I did not add this prefix, this course would be way too long due to all the errors I'd make. So for consistency's sake, I'm just going to keep this MTC prefix on all of my resources. All right, so let's go ahead and open and close those resource braces. And what we need to do is provide a VPC ID. Now, as you remember, when we ran our Terraform state list, we've got a list of our resources. And this is how we want to access this VPC resource. So what we're going to do is AWS VPC.mtc_VPC, which again matches this as well. And since this is another resource, it's like a variable, it's not a string, so you're not going to quote this. This is a reference to a resource, so you don't need to add quotes. And then what we need to do is just specify an ID. So if I do the Terraform state show AWS VPC.mtc_VPC, just like so, we can see that it has an ID attribute. And that's the ID that we need for our subnet. So we just specify that .id right there, and that's how you're going to reference most of the resources that you have to reference from other resources. So next we need to provide our CIDR block, and that's going to equal 10.123, and I'm just going to say .1.0/24, which of course is one of the subnets within this /16. And then after that, we're going to add our map public IP on launch. That's a long one there. Equals true, and since this is a Boolean, it's also not quoted. And then we need to provide an availability zone, just like so. And that'll be US West, and we're just going to use 2A, or at least I am, because I know A is probably good to go. There are ways to use what are called data sources to ensure that this is always correct, especially if you're using multiple availability zones, but we're not going to dive into that now, but feel free, of course, to research that if you are curious. So next up, we're going to add tags, and that name equals dev public. We'll just go with that. So the VPC we just named dev, and we'll just name this here as dev public so that we know that it's a public subnet. Again, map public IP on launch equals true is a good reason for us to want to make sure we label it correctly so we don't accidentally put sensitive resources in this subnet, which of course could cause a security nightmare. All right, so that's all we have to do for this subnet. Let's go ahead and run our Terraform plan. All right, we've got one resource to add, so that's good. An AWS subnet is going to get added. As you can see, everything we have specified is listed here. And of course, certain things like the ID are known after apply. So let's go ahead and run a Terraform apply. And then I'm just going to add auto approve. You're not always going to do this, but if you're running a plan first, it's usually pretty safe to go ahead and just auto approve it and not have to type that yes every single time. This especially is useful in automation. So I'll go ahead and run this. All right, one added, everything looks successful. So I'll go ahead and click on this sprocket next to resources, which again is in the AWS pane. And I'll go ahead and type subnet. As you can see, we actually do not have subnets available. This is a limitation of this AWS plugin. So we're not going to worry about it. But it looks like that subnet creation was successful. And of course, you can always go into the AWS console to verify. But everything looks good from my end, so go ahead and mark this lesson complete. Come on back to the next one and let's continue the course. Hello and welcome back. In this lesson, we're going to give our resources a way to the internet by creating an internet gateway. We'll then introduce Terraform format to clean up our code a little bit. So let's get started. As you can see here, the internet gateway is pretty straightforward. It's actually a really simple resource to deploy. We've got a few attributes here. These are the things that will be exported within our state. And these are the arguments: VPC ID, tags, and default tags. So let's just go ahead and knock this out. All right, so here we are. Let's go ahead and scroll down a little bit under our subnet, and we will add a new resource, AWS Internet Gateway, just like so. And we'll call that the MTC Internet Gateway. All right, and then I will open and close my braces. Let's add that VPC ID. And remember how we access this VPC. AWS VPC.mtcvpc.id, just like so. In fact, I can even copy this to save a little bit of time and just paste it in. And then just for the heck of it, I'm going to go ahead and add some tags. And we'll give it a name of dev IGW, just like so. So we've got our dev VPC, our dev public, and our dev IGW. So once we've done that, that's literally all we've got to do. But let's go ahead and introduce that fun new command. If you go ahead and run a Terraform FMT, just like so, what that just did was that corrected any type of inconsistencies we've got in formatting. As you can see, main.tf and providers.tf were both corrected. Now, unfortunately, I was not scrolled up, but as you can see now, all of our equal signs are lined up perfectly. So it made some very minor formatting changes, but it looks a whole lot better. So that's great. And if you want to see it in action, just go ahead and move that a little bit, run the command again, and as you can see, it automatically corrects. All right, so let's go ahead and deploy this brand new internet gateway. Go ahead and run Terraform plan, just like so. All right, one to add. As you can see, we've got our internet gateway that's going to get added. So let's go ahead and run a Terraform apply. Auto approve, just like so. Okay, apply complete. Everything looks good. Let's click on our AWS pane and let's see if we can access this resource. I'll just go ahead and type internet. Aha, AWS Internet Gateway, we've got it. So let's go ahead and check that and select OK. And if I expand my resources here and take a look under EC2 Internet Gateway, we'll see we've got two. So if I click on the one with the longer ID, we can see right here that we've got our Internet Gateway with the proper tag. All right, so that's great. Everything looks good. Go ahead and mark this lesson complete. Come on back to the next one and let's continue the course. Hello and welcome back. In this lesson, we're going to create a route table to route traffic from our subnet to our Internet Gateway. So let's go ahead and get started. All right, here I am in the docs. And as you can see, there's a note here. And basically, you can use a standalone route resource, or you can define routes in line. Now, in this case, they have the routes defined in line, just like so. We're going to do it a little bit differently. We're actually going to use a route resource, which, as you can see here, is also fairly straightforward, and we'll walk through this here shortly. So let's head back over to our route table. As you can see, all we basically need is the VPC ID, and then we'll provide some tags. So let's go ahead and do that. So I'll open my main.tf once again, scroll down some. Let's go ahead and create that resource, AWS route table, just like so. MTC public RT, just to keep it from getting too long, and open and close our resource braces. And within here, we need to provide that VPC ID again. And as always, I'll just copy this and paste it right there. And then we'll add some tags. Name equals dev public RT, just like so. So now that we've done that, once again, remember, we then need to add the AWS route, which is right here. And basically, we need to specify a route table ID, destination CIDR block, and in our case, an Internet Gateway. So let's go ahead and do that. So we'll create that resource, AWS route, just like so. Default route is what we'll call it. This is a default route, of course, for all traffic to get to the internet. Open and close those resource braces. Route table ID equals, and we're going to need to use the AWS route table, MTC public RT, AWS route table.mtc public RT. And once again, all we need to specify is the ID. It's asking for an ID. And pretty much universally, all AWS resources are going to have this ID attribute. So then we need a destination CIDR block, just like so. And that's going to be 0.0.0.0/0, which means all IP addresses will head for this Internet Gateway. And then again, that gateway ID is now going to be AWS Internet Gateway, just like so. .mtc, and as you can see, VS Code is providing me some nice little hints, so I'm just going to hit tab, Internet Gateway .id, just like so. And if we scroll up, we can see MTC Internet Gateway right here. All right, perfect. That's all we need to add. So let's go ahead and I'm going to scroll this up. Let's go ahead and run that Terraform plan. And we should have two resources to add this time. Perfect, two to add. We've got our route table and we've got our route. So that's great. Let's go ahead and run our Terraform apply, auto approve. And everything was applied successfully. Let's go ahead and click on the little sprocket next to resources and see what we have to offer. So what we've deployed is a route table, AWS EC2 route table, great. And then I actually do not see a route that we want to use, so we're just going to take a look at the route table. All right, here it is. It's going to be one of these. Dev public route table. Perfect. All right, so everything has been deployed successfully. Go ahead and mark this lesson complete. Come on back to the next one and let's continue the course. Hello and welcome back. In this lesson, we're going to bridge the gap between our route table and our subnet by providing a route table association. So let's go ahead and get started. As you can see here in the docs, the AWS route table association is actually pretty straightforward. Basically, we just need to access our subnet and our route table ID and just specify both of those in an association. So let's go ahead and knock that out. All right, so I'm going to go ahead and scroll down under this route here, resource, then AWS route table association, probably one of the longer resource names, MTC public, and I'll just call it an ASOC there, and open and close my resource braces. We need to provide our subnet ID. In that, we just scroll up and take a look. AWS subnet, MTC public subnet, and then once again, we just need to provide the ID of that. So, AWS subnet, autocomplete that, dot, MTC, scroll down here, public subnet, remove some typing and potential for errors, dot, ID. Just like so. So that's all we've got to do there. Then we need to provide a route table ID. And that, once again, we can just copy right from here and paste in. All right, so that is literally it. Let's go ahead and save. And then I'm also going to run another Terraform FMT just to clean things up. Look at that, much more beautiful. All right, and then let's go ahead and run our Terraform plan. Perfect, one to add our route table association. And we'll run a Terraform apply auto approve. All right, that is all set and all done. And if we want to see that association and some of the other things we've created, we can't access those from the resources. So of course we can always go to the console here. We can access the VPC area. Head to route tables. We've got our dev public RT right here. Take a look at our subnet associations. And there it is, our dev public subnet is associated with this route table. All right, so that's all for this lesson. Go ahead and mark it complete. Come on back to the next one and let's continue the course. Hello and welcome back. In this lesson, we're going to add a very important resource to our deployment, the security group. So let's get started. So here we are on the documentation. As you can see, here is an illustration of the usage of a security group. Now, in this case, they've actually defined the ingress and egress in line, which is perfectly fine. Now, you can specify them separately, as you can see by this note, as a security group rule resource, just like we did with a route resource. But this is perfectly fine. Now, in your organization, you may find a benefit to adding separate resources, but in our case, this will work perfectly. So as you can see here, the egress actually allows egress to everything on any protocol. That's 0 to 0. And then the protocol is -1, which means UDP, TCP, ICMP, etc. Any protocol you need to use, -1 will cover it. Now, the ingress only allows port 443, but we actually want to allow everything. We're just going to ensure that we hard code this IP to our own IP so that we don't allow someone to compromise our instance. So let's go ahead and get started. Now, sometimes I might actually choose to just copy this and paste it into my IDE and then modify from there to simplify things. But since this documentation may have changed by the time you watch this, we're going to type it out manually. So let's go ahead and start that. We're going to add our resource like always, AWS security group, just like so. And let's just name that MTCSG for right now. We'll open and close those resource braces. We'll create a name. That's dev SG, sounds good to me. Now, keep in mind, we don't need a tag here because the security groups actually have a name attribute. So there's no point in having to tag it. You, of course, could tag it for other organizational reasons, but as far as the name goes, this is perfectly fine. After that, we need to provide a description. Dev security group sounds great to me. We then need to provide a VPC ID, which we've used many, many times. I'm actually going to just scroll up, copy this, and paste it down here just like so. And then we need to provide our ingress and egress. So let's go ahead and add our ingress here from port. Make sure you have that underscore there, from port equals 0 to port equals 0. Protocol equals, in quotes here, -1. This is presented like a string. Terraform's not going to honor this negative right here, this dash. So make sure you specify this as a string. And then CIDR blocks equals. Now I'm just going to put in 0.0.0.0/0 because I don't want to show everyone my IP address. Make sure you only add your own IP address here, so you can go to what's my IP or somewhere else to find your IP address, and then that will be something, 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 something /32. That /32 indicates you want to use only this address. But again, I'm just going to put anything for right now, and I'll be sure to destroy my infrastructure that has this open port and replace it with my own later. Now, as you notice, this is CIDR blocks with an S, which indicates that it expects a list. Now, these brackets allow you to enter a list. So if you had multiple IPs, you could put a comma here and specify another one after that. But we only need one. All right, so our ingress is taken care of. Now let's set up our egress. Gonna slide this down a little bit. There we go. Egress from port equals 0 to port equals 0. Protocol, once again, equals -1. And CIDR blocks, in this case, I'm going to allow whatever goes into this subnet to access anything. So you won't put your IP address here. You will make sure you allow it to access the open internet. All right, perfect. So that's all we need to do there. Let's run a Terraform FMT to clean that up. There we go, beautiful. Then let's go ahead and run a Terraform plan and make sure everything works out. Slide that up. Okay, one to add like we expected. Looks like everything looks good here from port 0, protocol -1 to port 0. Perfect. Let's go ahead and run that Terraform apply, auto approve. All right, all complete. Let's scroll over to our AWS console. I will click on security groups. Go ahead and refresh that page. Here is our dev SG. If I open that, click on edit inbound rules, we can see all traffic is allowed on all protocols, all ports, custom source, and again, in my case, is 0.0.0.0/0. All right, perfect. So our security group is all good to go. Go ahead and mark this lesson complete. Come on back to the next one and let's continue the course. Hello and welcome back. We're almost to the deployment of our EC2 instance, but first we need to provide the AMI from which we want to deploy. To do this, we can utilize what's called a data source. A data source is basically just a query of the AWS API to receive information needed to deploy a resource. In this case, we need an AMI ID based on some filters we're going to provide. So let's get started. So if I head over here to my data source documents here for the AWS AMI, you can see an example. Data AWS AMI, and of course, data basically is like the resource keyword we've been using. We're just using data now. AWS AMI is the name of this data source, and of course, this needs to stay the same no matter what. And then this here can be whatever you want to name it. Now we'll be using most recent, and we'll be using some filters as well. Now one thing we have to make sure is that we have the correct owner. Now one way to do that is to use AWS Marketplace. But in our case, we're going to be a little more specific. Let's take a look at how to get the owner ID we need. So if I head into the management console here, Going to type EC2 up at the top. Going to open that. And if I go to instances and launch instance, let's take a look. I'm just going to type Ubuntu here. And I'm going to deploy Ubuntu Server 1804. That's one I've used in my other courses, and I'm just going to stick to that for now. 2004 should work perfectly fine, and whatever it is you want, you can choose. But in our case, we're just going to use this 1804. So what I'm going to do is copy this AMI ID because an owner ID is not provided here, which is a little annoying. And then I'm going to head back to my EC2 console, and I'm going to click on AMIs under Images. And right there, make sure you have public images chosen and enter that AMI ID. And here is our owner. So go ahead and copy that. You're going to need it here shortly. All right, so once we have that, let's head back over and start coding this thing out. Let me drop this a little and give it some room. So now what I'm going to do is actually create a new file for this. And we're going to call it datasources.tf. So I'll just create a new file and datasources.tf, just like so. And this will just keep things a little cleaner. So we'll use data, AWS AMI, and we'll just call it our server AMI or whatever you want to call it. We want to specify most recent equals true. And then we provide the owners. Now the owners, as you can see, is plural, so we're actually going to use brackets, which makes it a list. Go ahead and paste that owner ID that we got into here. And of course, if there are other owners, you could, but in this case, we just need that owner ID. All right, now that we have provided our owners here, let's go ahead and provide a filter to get the correct AMI. So if I type filter, just like so, name equals, and we're going to filter on name. I know this looks a little confusing, but the filter name is actually name. And then values equals, and once again, this is plural, so make sure it's in brackets, Ubuntu/images/hvm-ssd/Ubuntu Bionic-18.04-AMD64, make sure you have the right architecture there, -server, and then what we're going to do, since there's usually a date here, and we're just going to pull the most recent no matter what, we're just going to add an asterisk. So instead of the date that we would use here, we use an asterisk so that any date will qualify. So if I just head right back over here and take a look, you can see basically all we're doing is just putting an asterisk instead of this date, but everything else is exactly the same. All right, so perfect. So that's actually all we need to do. Go ahead and save this file. And then let's go ahead and run a Terraform apply. Terraform apply, auto, approve, just like so. All right, great. So now that is applied. So if I open my terraform.tf state right here, again, you would usually use a Terraform show, but this is a little bit easier for this. We can scroll down under resources. And you can actually see we have instances. Even though we don't have any EC2 instances actually deployed, there's still an instances section that contains this AMI data source. And if you look down, you can actually see we've got an image ID right here, which actually does not match here. And there's a reason for that. And that is if you look at the date 2021-11/29, the date of this one is actually 2022-01/04. So this is actually a newer instance than what is in the console, which is why that AMI doesn't match. And for our purposes, that's perfectly fine. So we now have an AMI ID that we can reference whenever we create our EC2 instance. So go ahead and mark this lesson complete. Come on back to the next one and let's continue the course. Hello and welcome back. In this lesson, we're going to create a key pair and then create a Terraform resource that utilizes this key pair. This will be used by the EC2 instance resource we create so that we can SSH into it later. So let's get started. All right, I'm going to first highlight my main.tf here, and then I'm going to go ahead and create that key pair. So to do that, and yes, I am on Windows. Windows actually does have an SSH utility. So I'm going to run the same commands that I would run on OS X or Linux, ssh-keygen-t, and we will use a more secure key than the typical RSA we use. Let's use ed25519 and hit enter. Now we're going to rename this key pair here. I'm just going to copy this instead of retyping it. Basically everything before the ID ed25519. And I'm going to paste that in. And then we're just going to name this MTC key. Or at least I am. Name it whatever you want here. Just make sure you reference it properly throughout the rest of the course. And I'll hit enter. We're not going to bother with a passphrase. All right, perfect. Looks like everything is good to go. Just going to run an ls/.ssh here. And that shows me that directory. And MTC key is there, and MTC key.pub, which is what we'll use for our key resource. So now let's take a look at the docs as we usually do. Resource AWS key pair. As you see, we basically need to specify a resource, AWS key pair, and then name that whatever we need to. We'll give it a name, and then we will provide the public key. Now we could just copy and paste the public key from our file, but that looks very, very messy. So what we're going to do is use a Terraform function. We're going to use the file function. So all we have to do is utilize file and then enter the path to our key. And what that will allow us to do is specify the key just like this, only much shorter by just passing it a path instead of the full public key. So let's go ahead and do that. So we'll start with resource, AWS key pair, just like so. After that, I'm just going to call it MTC auth. Open and close those resource braces. Key name, I'm going to go ahead and call that MTC key, just to keep things simple. And then we need to pass in that public key. And to do that, we're going to utilize the file function, and we'll quote this, and I'll use that /.ssh/mtc key.pub. And again, I'm on Windows, but these commands should all pretty much line up and be the same. So I'm going to go ahead and save that. Going to run a Terraform plan, make sure everything looks good. I'll scroll up here a little bit. All right, perfect. So the key pair will be created. Looks like everything passed those initial checks. So I'll run a Terraform apply, auto approve, just like so. All right, apply complete. So if I take a look over here in my AWS resources, we can see if this is one that is available for us. So I'll just type in key. Unfortunately, key pair does not appear to be one that we can see right here from this screen. So we'll just head back into the EC2 console. I'll click on key pairs. And there it is, MTC key, type ed25519. Everything looks great. All right, so that's all for this lesson. Go ahead and mark it complete. Come on back to the next, and let's continue the course. Hello and welcome back. In this lesson, we're going to finally deploy our EC2 instance. It won't have anything installed on it yet, but we'll at least get it scaffolded and deployed. So let's get started. All right, we take a look at our docs here. The resource is actually called AWS instance. As you can see in the basic example, it's using an AMI lookup, which looks very similar to what we have used before. As you can see, it's got the owner, it's got everything else here. Of course, we already saw how to get the owner ID ourselves, so that's great. And then basically, we just need to provide that AMI, and you reference that by using the data keyword .aws_AMI.Ubuntu ID. So do keep that in mind, where typically with a resource, we would just use AWS at vpc.myvpc.id for instance, but with a data source, you need to prepend that with the word data. And then we'll just provide a few more arguments. As you can see, there are a lot of arguments for the EC2 instance. So let's go ahead and start coding this thing out. All right, so what I'm going to do Let's scroll this down a little bit and let's add our resource, AWS instance, just like so. And I'll just call this dev node, just like so. Open and close those resource braces. We need to provide an instance type first. And to keep this in the free tier, we will use a t2.micro. Of course, you can scale that up, but that might cost you some money. And then we need to provide our AMI. So as you remember, the AMI in our data source here is data.awsami.serverAMI. So data.aws_ami.serverAMI, just like so. And then we just need to add ID to the end. And then let's add some tags. We'll just give it a name, equals, and we'll call it dev-node, just like so. Now, after that, we need to provide our key name, which of course we created recently. And what we're going to use is AWS key pair, which of course we just created right here, .mtc_auth.id once again. Now I see that this says key name and not necessarily ID, but the ID is perfectly fine here. The ID will work. Now if you take a look by just running Terraform state show AWS key pair .mtc_auth, we can see there actually is a key name. So if you want to be more explicit, you can absolutely use key name. ID is just a force of habit. It's something that I do frequently. As you can see, it is the same for both. So both works perfectly fine, but just know you can use key_name if you want to be more explicit. All right, so now that we've done that, let's go ahead and give this EC2 instance a security group, VPC security group IDs. You see this S here, which means, you guessed it, we need to use brackets. And I'm just going to do AWS_security and tab there to autofill that. .mtc_sg right there, .id. And of course, if you have multiple, you can use comma separation to provide multiple security groups. And then we just need a subnet ID. So that's going to be AWS subnet.mtc_public subnet, just like so, .id. Then, if we want to resize the default size of the drive on this instance, we can provide root block device, just like so. And you can actually up this. We can say volume size equals, you could say, we'll just say 10. We'll keep it in the free tier, which gives you 16. So we'll just say volume size equals 10, which is larger than the 8 that they give you by default. All right, so that actually is all we need to add for our instance for now. Let's go ahead and run our Terraform plan. All right, as you can see, we've got a lot of attributes there, but everything looks good to go. But actually, don't bother applying yet. We're going to go ahead and come on back to the next lesson and add some user data before we apply this instance, so we don't have to wait for it and then just redestroy it. So go ahead and mark this lesson complete, come on back to the next one, and let's continue the course. Hello and welcome back. In this lesson, we're going to utilize user data to bootstrap our instance and install the Docker engine. This will allow us to have an EC2 instance deployed with Docker ready to go for all of our development needs. So let's get started. Now, the first thing I'm going to do is just clean up this AWS instance a little bit. I'm going to cut this out, and I'm just going to take everything that's not in a block and place it together. So this will make things look a little more streamlined. So as you can see, we've got all of our arguments here, followed by the tags block and the root device block. And just to be consistent, I'm actually going to cut out this root device block and put it above the tags block, since almost everywhere we finish the resource with tags. All right, perfect. So that looks a lot better. So now let's add this user data. First thing I want to do is create the user data file. So I'll create a new file, and let's just call it userdata.tpl. Now this TPL actually stands for template. We're not using this as a template right now, but just in case in the future you decide to use it as a template, you can. And we'll take a look at templating here in the coming lessons. All right, so go ahead and take that script I've provided in this lesson and paste that in. Now this script, as you can see, is going to update apt. It's going to install some dependencies. It's going to download the Docker GPG key. It's going to add the Docker repository, update once again, install Docker, and then it's going to add Ubuntu to the Docker group, allowing you to run Docker commands as the Ubuntu user. I know that was a little quick. Feel free to reach out if you have any questions. So now that we've got this in, it's in our userdata.tpl script, and I have saved it, and this is in our root directory. Let's head back to our main.tf, and let's go ahead and add this user data to our resource. So what I'll do is just add user underscore data equals, and we're just going to use the file function here, and in quotes once again, userdata.tpl. So what this is going to do is extract the contents from our userdata.tpl file and use that to bootstrap our instance. So perfect, let's go ahead and see if everything works. Let's run a Terraform plan. All right, one to add. As you can see, we've got our EC2 instance here. Everything's looking pretty good. As you can see, our user data is hashed here. So if this user data were to change, it actually would change that hash and indicate that we need to redeploy our instance. So that's really, really useful. So now let's go ahead and apply. Terraform apply, auto approve, just like so. Now this is going to take a little bit, so feel free to pause and then come on back whenever your instance is deployed. All right, as you can see, the apply is complete. I'm going to head into my EC2 console, just like so. And as you can see, it's running, and I've actually had a few dead ones here, but this new one is running, but it's still initializing. So go ahead and pause the video once again, hit refresh a few times, and come on back whenever the status check is green. All right, so now everything is green. We've got 2 of 2 checks passed. Perfect. So now let's SSH into the instance. First of all, I need that IP address, so we can definitely just copy it from right here. But another way, of course, is to use our Terraform state. So if we do a Terraform state list, just like so, we then see our instance right here. I'm just going to copy that. Then I'm going to do a Terraform state show and hit that instance right there. And here is all of the information we can get. And if I scroll up a little bit, I've got the public IP address right here. Perfect. So now what I'm going to do is just do an SSH-I. Then if you're on Linux or Windows, you can use the /.sh/mtc key or whatever you name that key. Now, if I hit tab, that will actually correct it for Windows users, but it doesn't matter. It works either way. And then I'm just going to use my Ubuntu username and that public IP address. And hit enter, type yes, and bam, we are in the instance now. So if I run a Docker version, as you can see, we now have Docker installed and the instance is running. So go ahead and mark this lesson complete. Come on back to the next one and let's continue the course. Hello and welcome back. In this lesson, we're going to take a look at the configuration we're going to have to create to allow VS Code to connect to our EC2 instance. So first of all, if you haven't already, head over to the extensions and go ahead and search for SSH. And you should see this remote SSH app here. Go ahead and install that extension. Just like so. All right, perfect. So now that we've done that, you can go ahead and head back to the Explorer. And first thing I want to do is take a look at some example config files. So you should have a file now at your home /.ssh/config. So if I do cat ssh config, just like so, I can see here that I already have 2 entries. Of course, this is something I've done before. And what we need is we need to provide a host name, which happen to be the same here, and a user that we're going to use to log in. So what we need to do is provide the IP address of our instance on both of these host areas, host and host name, and then we'll utilize Ubuntu for the user. So how are we going to do that? What we're going to do is we're going to use template files, and we'll take a look into that very soon. But first, let's create the files. So go ahead and create a file based on your operating system, whether you're on Windows or Linux or Mac. Linux and Mac can both use the same script. Windows is going to be different. So I'm going to create both in this lesson. First, I'm just going to create windows-ssh config.tpl, just like so. And if you're on Windows, go ahead and grab that script, copy it, and paste it in. So basically what this is doing, and you'll need to replace your username here. Mine, of course, is Derek. Yours probably isn't Derek, but you might be. Go ahead and replace that. And then this is going to add the host name, user, and an identity file, which we didn't see before, but we do require, to our config. Now what we do is we actually specify the host name, the user, and identity file from our main.tf. And we're going to take a look at how to do that in the coming lessons. So go ahead and save this file if you're Windows. And if you're Linux, let's go ahead and create that one. So again, you can call this Mac if you want. I'm just going to call Linux SSH config for our file name. And this will serve for either Mac or Linux. And for that, go ahead and copy the script and paste it in. And what we've got here is we're actually catting into home.ssh/config. And then we've got the host name, user, and identity file, just as we did before. So go ahead and save that file if you're Linux. You can also provide both if you utilize both platforms like I do. So once you've done that, that's all we need to cover for this lesson. Go ahead and mark it complete. Come on back to the next one, and let's put these files to good use. Hello and welcome back. In this lesson, we're going to utilize a provisioner to configure the VS Code on our local terminal to be able to SSH into our EC2 instance. Now, a provisioner is not something you want to use for every deployment. Unlike other resources, a provisioner's success or failure will not be recorded or managed by Terraform State. So if something goes wrong, that's just too bad. There's no rollback or any other way to manage it other than just running it again. While this is not good for configuring remote instances, it's perfectly fine for something like this. All we're going to be doing is adding information to a config file on our local terminal. This is a lightweight operation that doesn't affect the overall success of the deployment if something were to go wrong. So with that being said, let's get started. First, we'll take a look over here at the provisioner documents. As you can see, provisioners are a last resort. Generally speaking, you're going to want to use user data, which of course we do, Ansible or Packer or Chef or something else, some other configuration management tool, if there's some sort of configuration we need to do on a remote instance. But once again, on our situation, it's perfectly fine. And we can use the local exec provisioner to allow us to configure local machines and run local commands. As you can see, basically we're running a provisioner, and in this case a local exec provisioner, within an AWS instance resource. Provisioners are always run within another resource. This could be something called a null resource also, but we're not going to look into that right now. Now another thing we're going to use is this self object here, which basically allows us to access this instance and access information. So if we need a private IP or public IP or whatever, we're able to access that right here using this self attribute. Now, something else you might notice, we've got this $ and braces here. That is interpolation syntax, and basically what that means is this is going to be replaced by whatever it is we're trying to use. So we've got a string here, but this here will be replaced by the private IP of this AWS instance. And you may have remembered that in our previous scripts. So let's go ahead and just get to work. So right over here, once again, we can take a look at our configuration files. And once again, remember these here, the same syntax, these are going to be replaced by the host name, the user identity file, whatever we need to pass in. So let's go ahead and start typing our provisioner. You're going to go to the bottom of our instance resource here. We're going to type provisioner, just like so, and then local -exec. We've been using underscores a lot throughout this script, as you remember, but this provisioner uses a dash. Make sure you remember that this is a dash or a hyphen and not an underscore. This is a mistake I have made many, many times. Open and close that provisioner block. Next up, we provide our command. Now this command is actually going to be run from these files here. And to run these files and pass in the variables necessary, we won't use the file function, we'll use what's called the template file function. So we take a look at the template file function here. You can see that basically you pass in vars after you pass in the path. So for instance, you can take a look at here, template file, and then this here is the path, which is using this interpolation syntax and path.module, which is a built-in variable. And then you use a comma. And then within an object, here with these curly braces, you pass in the variables that you need to pass in. So let's go ahead and do that. So for the path, in my case, since I'm on a Windows machine, I'm just going to use quotes, windows-ssh-config.tpl, just like so. If you are on Linux or Mac, you'll use the Linux version. And then after that, we need to pass in our variables. So I'll add a comma here. Then open and close some curly braces, and we will pass in these variables. I'm actually going to indent this. First up, we need our host name. Remember, we had to pass in a host name there. And that host name is going to be self.public_IP. Remember, we have a public IP attribute for our instance that we used before whenever we SSH'd into it. So we can just use self.public_IP here to access that. After that, we need to provide the user, and that's going to be Ubuntu because that is the EC2 instance username that we have. After that, we need to provide an identity file. So that identity file is going to be our private key. And the private key is located, we'll just use a tilde here, /.ssh/mtc key. Just like so. All right, so that is all of the variables we need to pass in. And then after that, we need to pass in an interpreter. Now the interpreter basically just tells our provisioner what it needs to use to run this script. Now it defaults to bash, so you don't necessarily need to add this for that, but we will just to be sure. So I'm going to add interpreter, just like so, equals. And since I'm on Windows, we're going to use PowerShell. And then we need to pass in the next command, which is -command. Now, if you are on Linux, and do not put both of these here, I'm just using this as an example. For interpreter, you're going to use bash, and we'll have a comma here, and then -c is the interpreter you'll use for Linux. But again, I'm on Windows, so I'm going to delete that and keep this here. All right, so once you've done that, that is everything we need to do, and this will hopefully create our instance, and it will replace the hostname with self.public_IP, the user with Ubuntu, and the identity file with this key here. So let's go ahead and give it a shot. Now the first thing we need to do is we need to run a Terraform plan. Pull this up some. Now as you can see, we've got no changes here. That's because the provisioner does not affect our state. It doesn't read that there's a provisioner there, and it's not going to change anything just because we added one. All right, so now that we've added our provisioner, go ahead and mark this lesson complete. Come on back to the next one and let's redeploy this instance. Hello and welcome back. In this lesson, we're going to redeploy our EC2 instance and finally see if everything works. So hopefully, when we redeploy this instance, this provisioner is going to run, add the information required to our configuration file, and allow us to SSH into the instance without any issues. So let's go ahead and give it a shot. So first up, once again, I'm just going to run that Terraform plan. And as you can see, no changes, which means that this provisioner is not going to run because Terraform hasn't detected anything different. Once again, it does not detect provisioners as differences in the state, so it's not going to trigger a run. So let's go ahead and take a look at a way that we can trigger that run. First up, I'm just going to run a Terraform state list again. And of course, we've got our AWS instance.dev node. Go ahead and highlight that and copy it. And then what we want to do is use a new command we haven't used, or at least a new flag. We've used Terraform apply a lot, but now what we're going to use is a -replace. Now this used to be known as Terraform taint, which would actually cause a resource to be replaced on the next run. But now instead, we just use -replace. I'll go ahead and paste in this instance.dev node here, and let's hit enter. All right, as you can see, we are refreshing the state. Okay, now we've got one to destroy and one to add. So it is removing and replacing our instance. And once that happens, it should run our local exec, replacing the content in our config file with what we need, and allowing us to SSH into our instance from VS Code. So let's go ahead and type yes and pause this video. Come on back whenever it's done. Of course, you might want to hop into the EC2 console. And once the instance shows up, is running, and has 2 of 2 complete and green, go ahead and come on back and we'll see if everything worked. All right, all of my checks are passed here. Let's go ahead and bring our editor back over. And this is now the moment of truth. First things first, I'm just going to cat my SSH config file. And this is a really good sign. Look at that. It looks like our provisioner did exactly what we asked it to. It added the IP address, the host name, our user, and the identity file to our config file. So now that that's happened, let's head up to View, Command Palette, and let's just type in SSH right here. And as you can see, remote SSH, connect to host. Let's click on that. And hey, check that out. So we've already got our IP address ready to go. Let's click on it. Opens a new window. This is a Linux host. Again, we're on a Windows terminal, or I am, but it's a Linux host. So choose Linux here. Yes, we are sure we'd like to continue. Looks like everything is setting up, downloading, installing VS Code Server. All right, let's open a terminal, new terminal. Bam, check that out. And if we run Docker, Docker is nice and installed. Once again, we can do a docker -- version. So now we have a perfectly good development environment ready to go. You can open up folders on the remote. Once again, home Ubuntu is a remote folder. So if I run that, I am now in a fully remote terminal. Go ahead, I can hit trust these authors. Bam, perfect. So this is really, really cool. All right, so looks like everything is working perfectly. Go ahead and mark this lesson complete. Come on back to the next one and let's continue the course. Hello and welcome back. In this lesson, we're going to start optimizing our script and making it more dynamic by adding variables. So let's get started. Now, so far, we've hard-coded pretty much everything. So now it's time to modify that to give us some flexibility so that we can adjust things easily without having to fish through every single attribute here, and instead being able to go to one file and modify what we need there. For instance, probably one of the things we're going to modify the most is the type of OS we're using. So since, for instance, I use Mac, Windows, and Linux quite frequently, there's a good chance I'm going to want to be able to modify which type of instance I'm using on the fly. So let's go ahead and take a look at that. Now, first of all, what I want to do is I want to use interpolation syntax to specify a variable here. Now, basically that variable will be calculated whenever we apply our script. So I'm going to use interpolation syntax, which I've mentioned before, and basically that's going to be a $sign and 2 curly braces just like that. So whatever happens here is going to be calculated dynamically whenever we run our script. So let's go ahead and name this variable. We'll call it var.host_os. So anywhere we need a variable, you specify it with var.variableName, just like so. So now if I choose Windows, then it will be windows-ssh-config, Linux, Linux-ssh-config, just like so. So now what we need to do is we need to initialize this variable and specify that, hey, we've got a variable that we're going to need to define. And to do that, we could either do it here in line in the main.tf, or what I prefer to do, and most everyone, is to create a new file for it. So I'm going to create a variables.tf file. Once again, it's analyzed just like any other TF file. It's all run at the same time, but this will just make sure that it's easier to find our variables when we need them. Now you can take a look here at the input variables documentation. Declaring an input variable is actually fairly straightforward. You use the variable name, and then within braces, you give it a type, and you can also give it a default. Now, the type is not necessarily required, but it is strongly recommended so that your other DevOps coworkers don't lose their minds trying to figure out what type of variable is expected. So let's head back over here and let's go ahead and build this. So it's going to be a variable, once again, host_os. Then we'll use our curly braces and we'll just provide a type, and that type equals string. We're not going to bother with a default yet, but we'll get to it. So now that we've done that, let's actually go ahead and perform a Terraform destroy auto approve. And as you can see here, it's actually asking for this variable to be defined now. So keep that in mind. Anytime you add a new variable, any destroy, apply, or plan operation is going to require that you define those variables. And we'll look at other ways to define them so that we don't have it popping up every time here from the command line. But for right now, we can just define it dynamically. So let's just go ahead, and I'm going to say Windows. If you're on Mac or Linux, specify Linux. But again, nothing really matters now because nothing is running. So go ahead and destroy this infrastructure. Pause the video and come on back whenever it's destroyed. All right, so everything is destroyed here. And just to illustrate once again, if I run a Terraform plan, it is going to ask me for that variable. So if I type that in, then the plan will run. So keep that in mind. Again, if you have variables that are not set, a plan, apply, or destroy is going to ask for those variables. So if you're in automation, that can break your automation. But anyway, now that we've got this variable initialized and we've taken a look at kind of how to use a variable within a script, let's go ahead and mark this lesson complete. Come on back to the next one and let's continue the course. Hello and welcome back. We've now seen how to initialize a variable and how to define it at the command line, but as we saw, that is not a great way to define variables when in automation, as it requires dynamic input, which is the opposite of automated. So in this lesson, we're going to look at a few other ways to define variables and which of those ways take precedence over the others. So let's get started. So first of all, let's take a look at the docs again, and if you scroll a good bit down, you can kind of see like we've got default values, custom validation rules. We've got a lot here that's actually really good information, but what we really want to see is if you scroll all the way down, you can see variable definition precedence. So basically, environment variables are processed last. So as we go down this list, these are processed in front of the others. So environment variables are processed last. So if you have an environment variable set, but then you define a variable in terraform.tfvars, which we're going to look at, then terraform.tfvars is the variable we're going to use. And then you've got terraform.tfvars.json, which not too many people use, but you can use it in automation. It does help sometimes. You've then got auto.tfvars and auto.tfvars.json, which are used in Terraform Cloud quite frequently. And then you can specify a var and var file option on the command line, but this isn't like a dynamic definition. It's not like it asks you for the definition and you type it. You just add this -var switch and then you provide the definition. And we will look at that. So let's go ahead and just take a look. What we're going to do is run the Terraform console. And this is a really good tool that will help you work with certain functions and play with different values and things like that that you might need to experiment with before you deploy. So if you run Terraform console, let's just take a look. As you can see, it did not ask us for a variable. So if I run var.host_os, you can see it's known after apply. So until we actually apply and specify that variable, then our Terraform console has no idea what that host OS variable is. So I'm going to go ahead and type exit to get out of the console. And what I'm going to do first is just add a default here. So go ahead and add default equals, and then specify your host, which again, mine is Windows, yours might be Linux. So now let's go ahead and run a Terraform console, and let's run var.host_os. There you go. So now it has processed it. Basically, the Terraform console has looked at all of our configuration files and saw that we have a default of Windows. So that's awesome. All right, so I'm going to get out of the console once again. Now what I'm going to do is I'm going to create a new file, and we're going to call that terraform.tfvars, just like so. Now this is the default name for our variable definition file. So here, all we need to do is define the variable. So host OS equals Windows. Or you know what? I'm just going to type Linux, since we're not running this right now. So now let's run a Terraform console, just like so, and let's run var.host_os. Now it's Linux. As you can see, terraform.tfvars takes precedence over a default variable set within the variables.tf. All right, so that's great. So now I'm going to get out of the console again. Now let's say we have, I don't know, a Unix system, or we want a different script that only works with OS X, and we want to specify that. Now, if we still have these two files, how are we going to override this value now that we have it defined in terraform.tfvars? Well, there are a few ways to do that, and one way is to specify the variable in line with our command. So if I run Terraform console -var equals, and we'll just say host OS equals, and Unix, just like so, now var.host_os is Unix. So if you need to override everything that you have specified in any file anywhere, you specify it right here in line. And again, this could be a Terraform apply or Terraform plan that you specify this var for, and this will override any other files that you've got. So now let's take a look at one more scenario. I'm going to exit once again. Let's say that we have a dev.tfvars. Now what matters is the tfvars, not necessarily the word in front. However, Terraform is going to process anything in terraform.tfvars by default. So if you have a dev.tfvars, and let's say that was host OS equals OSX, just like so, and we run a Terraform console, and then we run var.host_os, as you can see, it's still Linux, not OS X. So if we want to pass in this file, we just need to run Terraform console -var-file equals dev.tfvars, just like so. And now let's take a look. var.host_os is now OSX. Perfect. So now we've seen most of the ways that Terraform will process variables and the precedence it uses to decide which variable to use. So go ahead and exit out of this console and mark this lesson complete. Come on back to the next one and let's continue the course. Hello and welcome back. So now that we've managed to choose our SSH config file dynamically based on the definition of our host OS variable, we now need to make our interpreter dynamic. Unfortunately, this isn't as simple as interpolation syntax replacements. So we need to look at a better way. In this lesson, we're going to utilize conditional expressions to choose the interpreter we need dynamically based on the definition of the host OS variable. So let's get started. So what I mean by interpreter, of course, is this interpreter here, the one that determines what interpreter is going to be used to interpret our SSH config script. And if it's Windows, it's PowerShell, and if it's Linux, it's Bash. And as you can see, we can't just replace it like we did up here. That was very simple, and of course there are ways we could define this, but you know what? Since we know that it's only one or the other based on the host OS, I don't want to create a new variable just to do this. I'd much rather just continue using the same host OS variable. So if you take a look at conditionals here, conditional expressions, you can see basically you provide a condition, question mark, then you see the true value or the false value. So if host OS is Windows, the true value would be PowerShell and the false value could be Bash, for instance. So let's go ahead and just hop in and take a look at what this looks like. So I'm going to run the Terraform console and we're going to pass in a variable definition. Of course, we have it defined all over the place up here in our files, but we're just going to define it right here in line instead of messing with those files right now. So var equals host_os equals Windows, for me anyway, and enter. Let's verify var.hostos Windows. Perfect. So what we want to do is say if var.hostos equals, and we're using two equal signs here because we're not setting this, we are checking for equality, Windows, then first, we'll just say PowerShell, and of course this isn't the interpreter we'll use exactly, but just for the sake of using this now, this will be easier. Or Bash, just like so. As you can see, we got PowerShell. Now, if var.hostos is Linux, and we run this same exact command again, PowerShell, Bash, then we get Bash. So that's pretty straightforward. So what we want is we actually want this command and the other command, which of course I've also provided, and we're going to use those instead of just PowerShell and Bash. So we'll say var.hostos is Windows. Then what we want is in brackets here, PowerShell, comma, -command, just like so, and close that bracket. Or if it's not Windows, if this is false, then we just use bash, comma, -c, just like so. Let's hit enter. And perfect. Even though the formatting's a little wonky there, this will be perfectly fine. So go ahead and just copy this directly, Control-C that, and for interpreter, I'm just going to paste that in, just like so. And that's all we have to do. So let's go ahead and exit the console there. And let's go up to our terraform.tfvars. Make sure that is set to your OS. I'm going to go ahead and change this to Windows since that is the OS I am using. Variables.tf, the default is Windows, which is fine because terraform.tfvars is going to override it anyway. So if that's different, that is perfectly fine, but you may want to change this as well. And then once again, within our main TF, everything looks good. So let's go ahead and run a Terraform plan. All right, everything looks like it went through fine. So let's go ahead and apply it. Terraform apply, auto approve, and hopefully by the time our instance is fully initialized, we will be able to SSH into it just like we were able to before. So go ahead and run this Terraform apply, pause the video, and come on back whenever your EC2 instance is all green. All right, everything has come back just fine. We're running and all green. So let's go ahead and see if this new IP address is available for SSH. I'll actually take a quick peek, 34.219 for this one. So I will click on View Command Palette. I've already got remote SSH ready to go. And there it is, 34.219.246.58. Let's go ahead and see if it works. This is a Linux machine. I would like to continue yes. And everything is looking absolutely fantastic. We once again have our development environment all ready to go, but this time it's dynamic based on the host OS that we're using. So go ahead and mark this lesson complete. Come on back to the next one and let's continue the course. Hello and welcome back. In this lesson, we're going to add a nice little convenience feature to our script by utilizing outputs to display information we need. As you well know, we've been manually finding the public IP address of our instances to verify them. Well, that is incredibly inefficient, so let's go ahead and add an output to make this a little easier. So as you can see, we've got output values here, and basically it's incredibly simple to do so. This, of course, is how to access a private IP. Well, we're just going to access the public IP. As you can see, we've got a lot of other features as well, such as the ability to mark an output sensitive so that it doesn't show up on the command line. You've also got a depends on feature as well. We're not going to dive into that, but we are just going to go ahead and access that public IP of our instance. So if you run Terraform console, you can then access all of those attributes of our instance and kind of play with them to see what output we're going to get. As you remember, it is AWS instance dev node. So if we just type AWS underscore instance dot dev underscore node dot public underscore IP, there it is. So that's very, very simple. And as you know, you can use Terraform show or Terraform state show to get all of these attributes that you could use for outputs. So if I get out of this console, then run a Terraform state show, and of course, we'll just use, once again, AWS instance.dev node, just like so. We can see all of the possibilities that we can use to output. As you can see, we could output instance types, and here is public IP. So that's what we did. We just accessed that. So let's go ahead and create this output. What we're going to do is just create a new file, outputs.tf. Once again, you could add it to our main.tf, but we just want to clean things up a little. So output, and we'll just call this dev IP, open and close those braces, value equals AWS instance dot dev underscore node dot public IP. Just like so, that's all we have to do. Now to access this output, we may not want to destroy our entire deployment just because we added an output. What we can do is just run a Terraform apply dash refresh only. And that's basically just going to consider this output and add it to the state so that we can get to it. Just like so, as you can see, we've got changes to outputs. So that's perfect. So let's go ahead and run this. Apply complete, that's it. And then we can run Terraform output, just like so, to see our output once again. And this is very, very useful in automation. Now, if we take a look in our TF state, scroll all the way to the top, we can see our outputs are right here. So it's very easy to see what we need to see. So outputs are incredibly useful, and there's a whole lot you can do. You can get very creative with what types of outputs you get, but for our purposes, all we need to know is that IP address, which matches the one that we used to SSH into that instance. So go ahead and mark this lesson complete. Come on back to the next one and let's continue the course.